All right, so on Monday, everyone should have taken the functions pretest. Um, I'm going to go ahead and make the video notes now because looking at the results that have been turned in, that's kind of what I was thinking it would be. Out of the 12 questions, I think the average is a 4.5 right now out of 12 questions, right? So we're probably going to have to cover everything under functions, especially since we have some students that haven't learned it at all. So I'm going to go through the notes. These might take a little while. Um, you're going to have times where you're going to need to pause the video and try problems out on your own. But functions, the way I explain it to a lot of students, functions has a lot of things that you need to learn in the chapter, but they're not hard things. All of the problems you're going to have to do are pretty simple, and a lot of them are just look at something and tell the answer. You don't really have to work out and show work on these. So if we take a look, our learning goal, I can decide if a relation is a function and use function notation. So looking at that learning goal, we need to go over, okay, what is a relation? And then what is a function? So if we take a look first, we have this set of points. You have set A. It has the point 0, 0, 1, 1, 1, negative 1, 4, 2, and 4, negative 2. That's what a relation is. A relation is a set of ordered pairs. So what you need to do is go ahead right now, pause the video, get a piece of paper, get a pencil. You're going to have things that you're going to need to write down. Because like I said, easy topic, but there's lots of things you've got to know. So it works out a lot easier if you write these down and take the notes. So get a piece of paper. First, write down the definition for relation. What's a relation? A relation is a set of ordered pairs. So we've got set A. So what you need to do is write down the definition and then write down these points. So we have set A. And when you see the little symbol right there, that's just to show that this is a set of points. So we've got these 5 points. First thing we're going to talk about is what is the domain, and you will have an activity coming up in a few days where you're going to have to do questions on look at the set of points and tell what's the domain, what's the range. So you need to make sure you have this wrote down so you know. The domain is all of the x values. So if we look at these points, remember the number in the front is the x, the number in the back is the y. So we've got, what are our x values? 0, 1, 1, 4, 4. Now, when you write them down as a domain, you put them in order, least to greatest, and you don't list them more than once. Like if I look up here, I have a 1 here and a 1 here. So, but I only write it one time in the domain. You won't write 0, 1, 1, 4, 4. You don't need to do that. So the domain is the x values. So what are our x's? We have a 0, 1, and we have a 4 for the x value. Then when you have our range, the range is the y values. So what are our y's? We have 0, 1, negative 1, 2, and negative 2. So then you put them in order, least to greatest. So we have our domain and range. So write that down. That's one of your lessons this coming up. It'll be next week, I believe, for your work on that. Will be here's a set of points. Here's a relation. Tell what's the domain, what's the range. All right, so our domain is our x values, our range is our y values. A function is a relation where every x has one and only one y. So write that definition down for what is a function. A function is a relation. So a relation, remember that's just a set of points. So a function is a set of points where every x has only one y value. What that means is when you look, and for example, if we look at these tables, when you look at your x, each x has only one y. So if we look for 4, if x is 4, what's y? 2. So anytime x is 4, y can only be 2. So we couldn't have 4, 2, and then also 4, 7, or 4, 2, and 4, 8. That wouldn't work. Each x has to have only one y. So let's take a look and see in this table if that's true. All right, 4 goes to 2, -3 goes to 8, 6 goes to 1, -1 goes to 9, 5 goes to 6. The easiest way to look at this, and this might be something you might want to write down, take a note, the easiest way to remember this, because each x can only have one y, is all you got to do is look and see the x's. You cannot have the same number more than once. So if I look at this table and look at the numbers on the x side, do I have any of these numbers more than once? No, they're all different. And since they're all different, it's a function. It's a function because all of the x's are different. Whereas if I look at this table, is it a function? If it's a function, all of the x's will be different. So I've got 1, 2, -4, 1, 3. So is it a function? No, it can't be a function because you've got 1 on here twice. You have 1 going to 3, and you have 1 matched with the 4. You can't have that. So if you see on there, oh, I have the same number more than once on the x, can't have that. It messes it up. All right? Can't have that. Not a function. All right? Now, if we look over here, look at the third one, what do you think? Is it a function or not? Well, look at your x's. You have a 2, a 5, a 3, a -2, and an 8. Any of those the same? Nope, they're all different. And since they're all different, it's a function. Now, some people would look at them and say, oh, but look on the y. I have a 7 and a 7. That doesn't matter. You can have a repeating number on the y. That's fine. You just can't have any of your x's repeating. So it's a function because all the x's are different. It's a function because all the x's are different. This one is not a function because, oh, I have 1 on there 2 times. All right. So look at these 3 and you decide, pause the video, look at them, and you decide which ones are functions, which ones are not functions. See what you think. All right. So you should have paused the video. You should have done these already. If you haven't, then come on. You're not doing what you're supposed to be doing. Pause the video, work the problems out. So if we look at the first table, function or not a function? Well, we have 0, 5, -2, 4, 3. Any of those the same? Nope. So it's a function. Looking at the middle one. All right. 2, -2, -4, 3, -3. Any of those numbers the same? Nope. So it's a function. Looking at this one. 1, 1, 4, 4, 0. Any of these numbers the same? Yeah, I've got 2 1s, so it's not a function. I've also got 2 4s, so it's not a function. So, easiest way when you're looking at tables to decide if it's a function is just look at the x and see if anything repeats. You will have an IXL to work on that will go over, is it a function, yes or no? Should be pretty easy as long as you wrote these notes down and you have this. Write down an example. Write down one that is a function, one that's not a function, so that you can have on your paper and look and say, oh, okay, x's have the same number more than once, so it's not a function, or all the x's are different, so it is a function. So that should be pretty simple. All right. We also have to be able to just look at a set of points and say, okay, is this a function? But you do it the same exact way, just like in the table. In the table, you look at the x's and see, do I have the same x more than once? You'll do the same thing here. What are our x values? I have a 0. Remember, the x's are the numbers in the front of the point. So I have a 0, a 1, a 2, a 3, a 4, and a 5. So did any of the x's repeat? Do I have the same x more than once? No, I have a 0, 1, 2, 3, 4, and 5. They're all different. So since they're all different, it's a function. All right, so that's all you got to do. Look at the x's, see, do you have the same x more than once? If you don't, they're all different, then it's a function. All right, what about this one? What do you think? So we have -1, 1, 2, 0, 0, -2. Looking at the number that's only in the front. Do I have any of the same numbers? Any of the same number more than once? It's not a function. Why? Because you have 0, 0. You've got 0 more than one time. Remember, every x can only have one y, but in this case, 0 goes with a -8 and 0 goes with a 5. You can't do that. So it's not a function. Not a function. All the x's have to be different to be a function. All right. So just fill this in. The next thing we have is something you've probably never seen before, and it's another way to show points. You can show points in a table. I can just list the points out like we did on the last couple slides, or you can show points in what's called mapping. All right, so the way mapping works is you have the input, which is your x, the output, which is your y's. And all you do is, oh, I don't like the way this looks on here. So what I'm going to do is put it on here. So we have x, y. Maybe that's ugly. All right, so our x, -2, -1, 0, 1, 2 are our x's. Our y's are -4, -2, 0, 2, 4. 0, 2, 4. So what mapping is all you're going to do is, instead of a table, you just make an oval. All right, so I got an oval here and an oval there. And this is what's called mapping. On the x side, you put all of the x values in there. So I've got -2, make this smaller, -1, 0, 1, and 2. On the y side, I've got -4, -2, 0, 2, 4. So all you're doing for mapping is you're just drawing an arrow from the x to the y it's matched with. So all you're going to do is go to the map and draw an arrow showing what each x goes to what y. So -2 matches with -4, so all you do is draw a line from -2 to -4. You draw your arrow. That's it. It's just showing what the x is matched with. It's kind of weird. It's different. You haven't seen this, but it's just one other way to show a set of points. -1 goes to -2. 0 goes to 0. 1 goes to 2. 2 goes to 4. All right. So that's how you make a mapping. All right. We can look at another one. X, do this one in blue. Let's say you have X, Y, and you have X1, 2, 3. And for the Y side, let's say you've got 4, 5, 5. So you draw your map, one oval, two ovals, and now you say, okay, X side, what do I got? I got a 1, 2, and a 3. So I put them smallest to greatest, a 1, 2, and a 3. And on the Y side, what do I got? A 4, 5, and a 5. So I've got a 4 and a 5, and you don't write any number more than once. So I wouldn't write 4, 5, 5. I would just put 4 and 5. All right, you don't repeat any numbers. So now, what does the 1 go to? My 1 goes to a 4. What's the 2 go to? It goes to a 5. And then what's the 3 go to? It also goes to the 5. All right, so that's what mapping is. It's just a different way to write out a set of points and show what the X and Y matches to. Now, if that seems confusing, we're going to go over a bunch more of those so you can see how they're made, and then also how to tell if it's a function or not. So if we go back to our graph, to our notes. We did that one, showed all those. See, that's why I drew it, because I don't like the way they drew this, because you need to make it an actual oval. All right, so let's see. All right, let me go through these. I think I'm just gonna make some up for you instead. I don't like the way these notes do it. All right, so let's just take a look. All right, if we have x, y, let's say I give you, you have 0, 2, and 4, and 6. And then on the y side, you're going to have -3, 1, 5, and 1. So draw your oval. And then what I want you to do is pause the video and fill in your ovals and put your lines, and we'll see if you get the right look. So put in your x's. I have a 0, a 2, a 4, and a 6. On the y side, I've got, put them in order, smallest to biggest, a -3, 1, 1. So I've got 1, and then I've got a 5. Remember, you don't put 1 on there more than once. If you have something that repeats, you just leave it the one time. So 0 goes to -3, 2 goes to 1, 4 goes to 5, and then 6 goes to 1. That's all you're doing. All right, so hopefully that part makes sense. Now, how do you tell if it's a function or not? Really simple. When you look at the graph, remember, to be a function, every x can go to only one y. So all you do is look at this side, and you just see, all right, the 0, does it only have one arrow leaving it? Yeah, the 0 only goes to -3. The 2 only goes to 1. The 4 only goes to 5. And then the 6 only goes to 1. So it's okay if 2 arrows end up at the same place. This would be yes, this is a function. All right. However, here's an example of a no. Man, these ovals are terrible. All right. If I had 1, 2, 3, and then 7 and 10, and we'll add another number in here. Put a 3 here. So let's say we have this. Let's say 1 goes to 3, 2 goes to 7, but then this 3 goes to 3 and 10. So this would not be a function because 1 only has one arrow, so that's fine. 2 only has one arrow, that's fine. But 3 has 2 arrows. So that's no, can't do that. So that would be no, not a function. All right, so hopefully you're good with, here's a table, draw the mapping, but let's look at some more mapping ones just to see if you can tell if they're a function or not. So let's do a little bigger so you can see them easier. Let's say we have 4, 5, 6, 7, 3, 5, 9, and let's say it looks like that. Is that a function? Yes, it is. Each number only has one arrow leaving it. So yes, it's a function. But what if I changed it? What if I also said, oh, well, this 4 also goes to the 5? Then would it be a function? No. Why? Because the 4 has 2 arrows leaving it. All right? You can't have that. If you have that, then it's not a function. So that'll be another thing you'll have activities on, is to look at it and just tell, is it a function, yes or no? So if we look at these, which one is a function? Choice one, so is this one a function or is this one a function? So pause the video, look at them, see what you decide. All right, so if you did that, what you should have got was that choice one is the function. 3 only has one arrow. 1 only has one arrow. 0 only has one arrow. So you're good. Remember, they can both go to the same number, but they can't have more than one leaving the same number. Whereas over here, nope, it's not a function because the -1 has 2 lines leaving it. The -1's going to the 3 and the -1's going to the -2. You can't do that. That's a problem. All right, so let's look at these. Which mapping represents a function? Take a look, pause the video, decide which one you think it is. All right, hopefully you've got an answer. B is a function. All right, the second one. Why? Well, because over here the 2 has multiple arrows leaving it. You can't do that, so that's not a function. But over here, A only has one arrow, B only has one arrow, C only has one arrow. So B is a function. So this one is a function. All right, don't need to worry about that. All right, so this was a bell ringer that I would use for class, but this would be a good stop to see, do you know our 3 things that we learned today or have learned so far in this video? So I want you to just pause the video and then 1, 2, 3, write that down and just tell yes or no which one is, or is it a function, yes or no. Number 1, you have 4 points. Are they a function? Number 2, you have a mapping. Is it a function? 3, you have a table. Is it a function? So hopefully you've paused the video, tried these 3 problems. Let's see. Number 1, is it a function? Well, we look at the x values, the numbers in the front, and we see, do I have any of them more than once? I have a 3, a 6, a 0, and a 3. Uh-oh, I have a 3 and a 3, so no, it's not a function. Not a function. Number 2, what about the mapping? Is it a function? 10 has one arrow, 20 has one arrow, 30 has one arrow, 40 has one arrow. So yes, it is a function. Yes, it is a function. If we go to the table, is it a function? Well, look at your x's. Do you have the same number more than once? I have a 2, a 4, a 3, and a 2. Oh, I have a 2 and a 2. Since I have the 2 more than one time, it's not a function. So number 1, not a function because 3 and 3. Number 2, yes, it is a function. And then number 3, nope, not a function. I have a 2 and a 2. All right, so last thing we've got to talk about for these notes. I know these notes are a little bit longer because we have so much stuff packed in there, but they're pretty simple stuff so far. But next thing we got to know, how can you determine if a graph is a function? So what if I give you a graph? You use the vertical line test. All right, so if a vertical line can be drawn so that it intersects a graph more than once, then it is not a function. So write that down, and then I'll show you some examples. All right, pretty easy. So all you got to do is look at the graph and do the vertical line test, and it'll tell you whether or not it's a function. All right, so easiest way for that is to just come to this. I drew a graph. So let's say I have this picture on the graph. And then the question is it a function? So you use the vertical line test. All that is you look at the graph and you say, okay, if I drew a vertical line, is there anywhere I could draw it where it would hit the graph more than one time? So if I draw it here, oh, it only hits it once. What if I draw it here? Only hits it once. What if I draw it right there? Nope, only hits the graph one time. So since no matter where you would put a vertical line, no matter where you put it, it would only hit the graph one time, then your answer would be yes, that is a function. Yep, that's a function because draw a vertical line, I can only make it hit the graph one time. All right, so let's look at an example of what not a function would look like. All right, well, what if I drew, let me move my vertical line over here. What if I gave you this graph? Well, if I draw a vertical line, oh, I hit the graph here and there. So if you hit the graph in more than one spot, then nope, that would be no, not a function. All right, and it's that simple. That's all you're doing. You just look at it and see, okay, if I drew a vertical line, will I hit the graph more than once? So what if I drew that? Well, right here, oh, only hits it once, only hits it once, only hits it once. But if I draw it here, oh, look, it hit it 3 times. So nope, not a function, not a function. What if I drew that? And you got that on a graph. Well, only hits it once, only hits it once, only hits it once. No matter where I put this line, it only touches the graph one time. Only touches one time there. Only touches one time there. So that is a function. It is a function. So if you can only hit the graph once, it's a function. If you can hit it more than once, then it's not a function. What about this one? Oh, I put it right there. I hit it there and there. So not a function. Does not pass the vertical line test. So if we go back, say I have that, would be a function. It only hits it one time. Whereas that, I can hit it twice, so not a function. So we'll look at some. All right, what if I have that? What do you think? If I draw a vertical line, can I hit it more than once? Nope, so it's a function. What about that one? Draw a vertical line, I can only hit it one time, function. What about this one? Well, I have a vertical line, so if I drew a vertical line on top of it, I would hit that line at all kinds of points. So that's not a function. What about this one? Well, draw a vertical line up and down. No matter where I put it, I can only hit that one time. So that is a function. All right, you try these 3. Look at those, pause the video, and then you decide which ones are functions or not functions. All right, so what you should have had, if you look at the first one, if I draw a vertical line, oh, yep, if I draw a vertical line, I can hit it more than one time. Right, look at that, hit it twice. So that's not a function. What about this one? Well, no matter where I draw that line, I can only hit it one time, so it is a function. And then this one, what do you think? Well, if I draw a vertical line right there, I can hit it in 2 spots, so not a function. And our last one, if you have an oval, well, yep, hit it in 2 spots, so not a function. All right, so that's the vertical line test, pretty simple. So here you go, 4 examples. Pause the video, give them a try. These are the 4 things we've learned. Can you look at a map and tell, is it a function? Can you look at a graph and tell, is it a function? Can you look at a table and tell, is it a function? Can you look at mapping and tell, is it a function? So go ahead and give that a try. All right, if we look at the first one, is it a function? Yes. Each of these only has one arrow leaving it, so it's a function. Number 2, well, look at your x's. Do you have anything repeating? Oh, they're all -3. So, yep, you have the same number more than one time, so it's not a function. Number 3, does it pass the vertical line test? Nope. If I drew a vertical line, I could hit that 3 different spots, so it's not a function. And then number 4, function or not a function? Nope, not a function because the -2 has 2 arrows leaving it. You can't do that. So I have more than one arrow leaving it, so it's not a function. All right, so that's the main thing for this lesson so far. Can you look at these things and tell, is it a function or not? All right, bell ringer, I'm not worried about that. And not worried about that right now. All right, so we're good for our notes for telling whether or not it is a function. So if you have a question, let me know. We'll do our Google Meets all this week, so you can pop in, ask questions if you need to. You can email me your questions. I'm going to post the assignments once a day from now on, and they're going to be due at midnight each day. Because when I posted all of the assignments early, we had people get mixed up on what they were doing and too many missing assignments. All right. Now, you can always check our calendar, because if you go on there and you look and you find the link on Google Classroom that has the calendar on it, I've got all your assignments for the next month on there if you want to do some of them ahead of time. But anyway, here you go. This is going to be your lesson, your assignment for let's see, Tuesday, which will be December 1st. Your assignment is going to be to watch this video. So if you have any questions, let me know.